So friends, so far in this chapter we have seen, this chapter Wonders of Light part 1, we have seen what is mirror, we have understood what are the different laws of reflection, we have seen different cases of position of object placed in front of concave mirror and also in front of convex mirror. We have seen why there are 6 cases possible in concave mirror and why only 2 cases are possible in front of convex mirror. To understand this particular thing better, I have drawn a comparison chart here which I will explain, and also we have seen that in theoretical question, when data has not been given and the question asks you what are different places or position where the image forms, what is the nature of image, real or inverted, whether it is erect or inverted. We have seen when in those questions where data has not been given, then how also we can conveniently solve that question by taking r is equal to 10 and f is equal to 5 for concave mirror also and for convex mirror also. Now let us understand the comparison between concave and convex mirror. What are the points which are common and what are the points which actually distinguish concave mirror from convex or convex mirror from concave mirror. Now we have seen this is how a concave mirror looks. If you remember I have used my hand. If this is a plane mirror, if you see from that side it will look like a line. If this is a plane mirror, if you bend inwards then it becomes concave mirror, and if you bend like this it becomes a convex mirror. In this particular case you are seeing the hand from this side. If you bend this way it becomes a concave mirror, and if you bend this way it becomes a convex mirror. Correct? Now we have also seen and understood why there should be a center of curvature, what is center of curvature, and how this focus point comes into picture. Correct? If you remember, if you recall, I have taken an example. If you see broken part of a bangle, the first thing which comes into your mind that it might be a shape of a ring, that bangle, and that piece of arc comes from the same circle. Correct? So by seeing this arc, we can imagine if it would have been a circle, there would have been a center of curvature, and focus is the point where after reflection all the rays are supposed to meet. We have also seen for small apertures of spherical mirrors how small f, that is focal length, should be half of radius. Correct? Now this is how a concave mirror looks, and if you see, the center of curvature and focus point both lies on left hand side, and that is why this is how it divides. If I draw this y-axis and mark pole as the origin of this Cartesian system, then these 2 points divides the negative x-axis into many intervals, and then we have generated, or we will be having different positions of object, and they were coming out to be 6. How? The very first was the object was placed at infinity, at a very far distance. Correct? Now if we bring the object near to center of curvature, the second point or the second position of object can be beyond center of curvature. Right? That we have seen as second case. The third case which is possible is object placed at center of curvature itself, and if you move further towards this mirror or pole, the next point should be between center of curvature and focus point, which was your fourth case. The fifth case was turning out to be the position focus point itself, and the sixth case, finally the sixth case was the object placed between focus point and pole. Correct? Whereas if you see this convex mirror, both center of curvature and focus point lies behind the mirror. So now object cannot be placed behind the mirror, the object is supposed to be in front of the mirror. So this number line or this principal axis, if I draw y-axis over here, making pole as the origin, correct, then there is no single point which divides this negative x-axis, which is the front part of the mirror. Correct? So we have only 2 possible cases, that is the object might have been placed at a very far distance from the mirror, or the object is near to the mirror. Okay. That is why we have only 6 cases in concave mirror, and whereas we have only 2 cases in convex mirror. That is because of the division of line by the center of curvature point and focus point. Now if you see the second point, the first formula I have written over here is 1 by v plus 1 by u is equal to 1 by f. where V is what? Distance of image from the pole, which we have calculated. If you recall, we have calculated for different cases, 6 cases of concave and 2 cases of convex mirror also. And U is the distance of object from the mirror, that particular cases, 6 cases and 2 cases of convex mirror. And this small f is the focal length, that is distance of focus point from pole. Correct? And for theoretical question, I have been kept on saying this continuously, that you have to consider, for just an ease for the convenience of calculation, you have to consider r is equal to 10 and f is equal to 5, which automatically it becomes 5 because f is equal to r by 2. Just because the question is theoretical question and still it asks about nature of image, size of image, position of image, etc. etc. Correct? The second formula is h2 by h1 is equal to minus of v by u. Now this h2 is what? This is vertical length, the height of image. H1 is what? Height of object. Now also remember, v and u are distances calculated in horizontal direction or along the x-axis or along the principal axis. Whereas h2 and h1 are vertical distances, vertical lengths, or betterly called as height of image or height of object. Correct? We have used the two formula, mirror formula and magnification formula, in concave mirror cases also and also in convex mirror cases also. I have written here, if you can see, this is 1 by v plus 1 by u is equal to 1 by f, mirror formula for convex mirror, and h2 by h1 is equal to minus of v by u, the same magnification formula for convex mirror, where h2 is height of image and h1 is height of object. Now third point I have written over here, which you can now appreciate, you have understood that that there are 6 cases possible of position of object. Correct? I have just explained, I have explained it earlier also why there are 6 cases, and in case of convex mirror there are only 2 possible cases. Why? Because there is no division of line, there is no point marked on negative x-axis, which is the front axis of convex mirror. Correct? So one point can be very far and one can be very near to the mirror itself. Also, if we see the fourth point, there were 5 cases turning out to be the cases where you found real images. There were 5 particular cases. What were those cases? The very first case was when the object is placed at infinity or at a very far distance. In that case also, the object, when the object is kept at infinity, in that case also, the image was turning out to be real image. If you remember what is a real and virtual image, if the image is formed in front of the mirror, then that image is real, otherwise it is virtual when the image is formed behind the mirror. So there were 5 cases in which real image was seen. The very first case, when the object is placed at infinity beyond center of curvature. Second case. The third case, when the object is placed at center of curvature. Fourth one, when the object is placed between center of curvature and focus point. And the fifth case, when the object is placed at focus point itself. In last case, when the object is placed between focus point and pole, in that particular case, the image was coming out to be virtual. Why? Because that image was forming behind the mirror. I hope you remember. If the image is formed in front of the mirror, the image will be real. If it is formed behind the mirror, the image will be virtual. Whereas, when we came to convex mirror cases, only 2 possible cases which we have seen. In both the cases, the image was turning out to be virtual. There was not a single case where we have seen a real image. Why? Because every time from calculation, the value of V, that is distance of image from pole, was coming out to be positive, and which means the image is forming behind the mirror, so it should be virtual. Okay? That is the major difference between concave mirror and convex mirror. There are 5 cases where you can see real images in case of concave mirror, and 1 case is where you can see the virtual image. But in all cases, 2 cases of convex mirror, the image formed was virtual. Now, if you see the 5th point, that is also an important point in numericals when you have data given in the question and you are supposed to calculate V, U, F, or height of image or the height of object itself. Focal length of concave mirror is always negative. You would appreciate this if I say that since focus point is lying on negative x-axis, that point should be negative. This length in magnitude you can say is positive, but since it is marked on negative x-axis, then it should be negative itself. Correct? Why? Because if we draw this vertical line as y-axis, which is passing through pole, and pole is considered to be origin in all the cases, if we draw this Cartesian system, then obviously you can see this focus point is lying on negative x-axis, which makes or which tells us that focal length of concave mirror should be always negative. Remember, always negative while calculating. We'll solve question numericals and we'll see that we have taken focal length always negative, or by calculation also it is coming out to be negative when it is concave mirror. But when we talk about convex mirror, you see focus point is lying on right hand side of this pole, and pole is acting like an origin if I have drawn a y-axis along with this principal axis acting as x-axis. Correct? Now since focus point is lying on right hand side, then the length should be positive. Why? Because this particular point is lying on positive x-axis. So do remember, focal length of a concave mirror is always negative in all cases, whereas focal length of a convex mirror, I am talking about mirror, not lenses, we will come to the lenses later on. Focal length of a convex mirror is always positive because focus point is supposed to be on the right hand side of the origin in case of convex mirror. Now, if you see the sixth point, concave mirror is always a converging mirror, whereas if you talk about convex mirror, then it is always a diverging mirror. Now friends, let us understand what is converging, what is diverging, or the phenomenon convergence or divergence. Suppose if you see my hand, once again I will explain this particular point with my hand. If you see my hand, suppose this palm is the source and these fingers are the reflected rays. If I spread my fingers away from each other, then you can see from this source, if you can see from this source, these rays are separating from each other or are running away from each other. This is called as divergence. Separating from each other. So it means if you have a point source and rays coming out from there are separating from each other, then this means divergence. Then what about convergence? Exactly opposite. When all the rays meet at a particular point, then that property is called as convergence. Now suppose if I take, see these chalks, if I take these chalks and suppose the point where I hold these chalks together is that point source from where the rays are coming, then you can see this yellow, white and green chalk which you see are the rays coming from this point source and are running away from each other, separating from each other. Then this property is called as convergence. I'm really sorry, divergence. But if I hold them in this manner where they are going to meet at a particular point, see, if you see these three chalks, you can say, sir, you already have explained this property as divergence. But you understand, these rays are coming in towards this particular point, and in earlier case, these rays were going away from that particular point. It means when the rays are coming towards a point and meeting at a common point, then this property is called as convergence. But if these rays are going away from the point source and are moving away from each other or are separating from each other, then this property is called as divergence. Now I have drawn here. Also friends, understand, we have not seen ray diagrams, we have just seen the different cases of position of object kept in front of concave mirror or convex mirror for theoretical questions only, not for numericals. And for theoretical questions we have assumed radius to be 10, so automatically focal length became 5, and we have calculated or we have seen what will be the size of image, what will be the nature of image, etc, etc. Correct? We are yet to see ray diagrams, which I will explain after this particular topic. Now if you see this diagram, this white ray is coming towards concave mirror, above the principal axis also and below the principal axis also. This white ray this ray also. So these two white rays are coming towards the concave mirror. Now after reflection, they are moving towards each other and going to meet at a particular point. Now this phenomenon is called as convergence. Now why concave mirror shows these properties? Understand. Since the mirror is curved in towards the center of curvature this way, if a ray comes from here, it is not going to break the mirror and go at the top. But since this mirror is inverted towards in this pattern, this particular ray will hit the surface and will move towards the center. Correct? So in this property is called as converging or convergence. Concave mirror is always converging mirror, but if we see convex mirror, then this particular case is a divergence mirror. How to better understand this? See, you take a big bowl, big metal bowl, and you keep it in this manner, okay? And you try to hit a ball in that particular big bowl. It is a big bowl. I am showing with my hand in a comparison level. It is a big bowl, hemisphere, hollow from inside, and you are trying to hit a ball. If you hit the ball on the walls of this particular hemisphere, then what will happen? That ball will be reflected towards the center. The moment you invert it, the moment you invert this particular bowl, which means the curved part is at the top and the hollow part is below the that particular surface, which means towards the lower surface, earth. You take the earth example. Now if you hit the ball on the top of this curved surface, what will happen? It will move away. It will not be towards the center. It describes us, it tells us all those shapes which are like concave mirror are converging. But since we are talking about rays only, so this particular concave mirror is converging for incoming rays, whereas this convex mirror is diverging for incoming rays. So these are 6 points which we have seen, and after this we are going to see ray diagrams. We'll understand what are the different rules to draw a ray diagram for a particular case. Doesn't matter whether the object is placed on the center of curvature or focus point at infinity. We will draw ray diagrams for all 6 cases of concave mirror, and also we will see the ray diagrams for the 2 possible cases of convex mirror.
No more spending your energy and money on coaching classes, or missing classes for rain, for rally, and any other nonsense. Subjects covered by multiple teachers with repeat telecasts. Doubts, concepts, applications, no problem. All explained through great and significant animation. So sit back comfortably in your home and watch Study Spectrum TV channel.
So friends, so far in this chapter, Wonders of Light Part 1, we have talked about how we can see objects. That is what the importance of light is. We have talked about plane mirror. We have talked about the nature of image formed when the object is placed in front of a plane mirror. We have talked about the types of spherical mirrors, that is concave and convex. We have seen how for theoretical questions, when no data has been given, but still the question asks about the nature of image, size of image, position of image, etc., etc., how it can be calculated and how those questions can be answered by taking always r is equal to 10 and f is equal to 5, both for concave and convex, with signs, minus for concave mirror and positive for convex mirror, because the focal length comes out to be, or the focus point lies in front of the concave mirror, and when we make pole as origin and it falls on negative x-axis, whereas in case of convex mirror it falls on positive x-axis when we make pole as the origin by drawing the y-axis passing through pole. Also, we have seen 6 different cases of position of object placed in front of concave mirror, but we have seen only two possible cases of position of object when placed in front of convex mirror. Correct? Now we will again see those 6 cases of concave mirror and 2 cases of convex mirror, and we will draw ray diagrams for all those cases, 6 cases of concave and 2 cases of convex mirror. Correct? Before that, let us understand what are the different rules for drawing a ray diagram for those cases and how it can help us to answer those questions, theoretical or numerical, and draw diagrams for those cases. Correct? So let us understand there are 3 basic rules to draw ray diagrams for concave and convex mirror. If we talk about concave mirror, then the very first case is, if suppose this is concave mirror, correct, and this line is your principal axis. Okay, which means this point is pole, and it means if suppose this point is center of curvature, then this point should be focus, where all rays after reflection are supposed to meet. Okay, now let me say I will use symbol I for incident ray and symbol R for reflected ray. I for incident ray and R for reflected ray. Now the first rule is, if the incident ray, this is your incident ray coming towards the concave mirror. If this incident ray is parallel to the principal axis, then the reflected ray should always pass through focus point. I have used green color for incident ray and yellow color for reflected ray. This is your I and this is your R. If the incident ray is parallel to principal axis, then the reflected ray should always pass through focus point. Correct? If the second case is, if the incident ray is passing through focus. If suppose this is your incident ray which is going to pass through this focus point. Okay, this is I and this ray is incident ray. Is going to pass through focus point, then it means the reflected ray should be parallel to principal axis. So you can see here, this incident ray is coming towards this concave mirror, passing through focus point, and this resulting reflected ray after reflection is going to be parallel to principal axis. This is rule number 2. The first rule was just opposite to this one. The green line which I have used for incident ray, that incident ray was parallel to principal axis, the very first rule. That incident ray was parallel to, I will draw it in white color over here also, so you can just recall. This incident ray is parallel to the principal axis. Suppose this is focus point and this is center of curvature. Then the reflected ray will pass through focus point. And the second case is, Second case is, this is your axis, this is your say focus point, and this is your center of curvature. If the incident ray is passing through focus point I, then reflected ray should be parallel to principal axis, which I have drawn with a larger view here with colors. I, incident ray, green color, is passing through focus point, and after reflection this reflected ray gets parallel to the principal axis. That is your second rule. The third rule is, if the incident ray passes through center of curvature, then what? I will mark this point again. This is your focus point, its mirror, and now the incident ray is going to pass through center of curvature. Suppose this is how it is passing through center of curvature. This is your eye. This is your eye. This incident ray is passing through center of curvature. Then after reflection, this time it will pass through same center of curvature. Okay, so if I say this is the line which is coming, ray which is coming towards center of curvature, then I and R are going to be in a single line, the same line. If the incident ray passes through center of curvature, then the reflected ray also passes through the same line after reflection through center of curvature. So if I draw the third rule over here also, if this is your concave mirror, this is your principal axis, this is your focus point, and this is your center of curvature. So if this is the line through which incident ray is coming and passing through center of curvature, then after reflection it passes through the same line through center of curvature. So the first rule is, this is your first rule, this is your second rule, and this is your third rule. What is the first rule? If the incident ray, I have used the symbol I for incident ray, you can see I written in white color over here. If the incident ray is parallel to the principal axis, then definitely the reflected ray should pass through focus point. Rule number 2 is exactly opposite of this, that is exactly opposite of the first rule, that is if incident ray is passing through focus point, then the reflected ray should be parallel to the principal axis. Okay, if I is parallel, R passing through F, I parallel to say axis, it results into R through focus point F. If I passes through focus point, then reflected ray parallel to principal axis. Okay, I have written over here also. If incident ray is parallel to axis, principal axis, then the reflected ray should pass through focus point, and if I is passing through focus point, then the reflected ray should be parallel to the principal axis. And the third rule, that is very important. If the incident ray is passing through center of curvature, then after bouncing, after reflection, the same reflected ray should pass through the same line through center of curvature. Okay, so please do remember these 3 rules which we are going to use in different cases of position of object when placed in front of concave mirror, that is 6 cases. The first case was the object placed at infinity, very far distance, the object placed just before center of curvature or beyond center of curvature rather. The third case at center of curvature, fourth case between center of curvature and focus point, fifth case at focus point, and sixth case the object placed between focus point and pole, and in that particular sixth case the image was turning out to be virtual. In all other cases, the image was turning out to be real. And it means when we draw the object on the left side or in front of the concave mirror for the earlier 5 cases, we have to draw images in front of the mirror itself, because the images will be real. Doesn't matter erect or inverted, but it will be drawn in front of the concave mirror itself. So these are the 3 rules which are important for drawing ray diagram. If incident ray is parallel to principal axis, then the reflected ray will pass through focus point. If the incident ray is passing through focus point, then the reflected ray will be parallel to principal axis. And if the incident ray is passing through center of curvature, then the reflected ray will also pass through the same center of curvature, or in other words, a single line will be there for both incident and reflected ray. They will meet